So I'm from eBay, so you should not be expecting a lot of technical stuff that WSO2 engineers have been telling you for, what, 6 sessions now. So it's not going to be overloaded with technology. So it's more about the challenges that we happen to face while we migrated to cloud. And what was it before we went into cloud is the first thing that anybody would ask us. So we were running on bare metals, and we had to move to the cloud. And why did we have to move to the cloud? We had one strong reason. Oh. Okay. It's getting my house slide. Okay, that's one of the problems. So half of what we got came through. Oh, okay. So while we are doing it, so we were on the bare metal, and we wanted to move on to the cloud. And what I was about to show you was it was not just for the namesake where we wanted to be on the cloud like any other product. We in eBay have a very huge private cloud, one of the biggest, I would say, and pretty good at it. So other products actually went on the cloud, and it was not just that we wanted to be on the cloud, not for the namesake. So what we ended up doing is we moved from bare metal to VMs on the cloud. And what cloud gives us basically is, so we are one of the maybe earlier customers of WSO2, and we have our ESBs running over a couple of years or much more than that. So we had a lot of legacy configurations and legacy implementation of ESB that kept running on the bare metal, so we had a lot of things to take care of there. Okay, looks better. So, well, we missed the part of why we moved to the cloud. I told you, not necessarily this. Not that we wanted to be on the cloud and we didn't want to call ourselves as a service, but definitely this. We wanted all the lifecycle management that we got out of the cloud. What I mean by lifecycle is infrastructure, the first thing, definitely. We wanted to have a flex up, flex down whenever we want more load to be taken, and we definitely didn't want a lot of capacity lying around waiting for the traffic to come in, but definitely want to increase the capacity as and when needed. So infrastructure lifecycle, platform lifecycle, and what would that mean? That's basically a lot of our software which integrates with the eBay ecosystem. So that continuously keeps evolving, and we wanted the right tools to be enabled, metrics to be enabled, and all of that would be taken care of by going to the cloud. These are basic things about cloud, nothing very specific to ESB right now, but well, this is something any product that migrates to cloud may want to consider. So it may sound like comedy of errors where we made some mistakes. In hindsight, they look not really foolish, but lessons to be learned from. But yeah, that's what happens when we migrate to cloud. So these are some of the things that we'll have to worry about. We definitely need the, yeah, I just mentioned the metrics and analysis that comes part of our cloud had to be enabled. We wanted our capacity to be taken care of, and cloud is all about optimal resources. So we don't want to give more resource, or we don't want to give it less resource. So it had to be completely automated where flex up and flex down happens naturally as and when the traffic increases. So this was the real reason, unlike what Dilbert was mentioning. A very, very basic view of our cloud. We have our hardware, which is part of our IaaS, and we have our virtualization setup, which is part of our PaaS. We have our platform, where we have all the eBay infrastructure and eBay framework built into it, which is, I would say, mostly JVM and a container that we have modified for our own usage. And over this is ESB, or any other eBay application, for that matter. And does it sound even difficult to move a ESB from bare metal to just keep it running on top of all of this? It sounded simple to us anyway, but it took us a couple of months to get it running there. So some of the basic problems that we found is what I'll discuss. And I'll try to run it fast, so we may have some time for discussion. If somebody is interested, we can go deep into all of these problems. It certainly took us a couple of months, so I have a few hours of talk I can continue with if I were to discuss each of them in detail. So I'll just run through, and if somebody is interested, I can go deeper into it. So, well, basic cloud problem. Hardware is good, but we always get heterogeneous hardware in cloud. We can never always tell that we want a particular type of hardware, a particular type of processor, and certainly not the same network capabilities, and obviously memory. Memory was something easier to take care of, not much of variation, but definitely processor and networking. And what cloud always guarantees is you want power, we'll get you enough compute power, but don't ask us which processor you want. Well, that's how it is. So, but did it matter for ESB? Definitely yes. ESB is a different animal altogether. Most of our applications were either compute intensive or memory intensive. ESB turned out to be network intensive and relied a lot on our caching, which I'll come to later. Oh, sorry. And virtualization. It looks so simple, right? So we have a bare metal. We put a hypervisor on it and cut them into smaller pieces, get ourselves the VM. But the interesting part, what are the problems that we have with virtualization? We have noisy neighbors, and it's a very basic concept. You have VMs which sit next to each other, and each of the applications running on the VM try to contend on the same resource, they all get less. If they don't contend, all of them get more. So idea is you should be able to share the resource such that the VMs that are running have the applications which have a good mix of compute, memory, and network, so that all the resources that we have, basically the hardware resources, are optimally used. That's a challenge which we expect the cloud team to take care of, which in eBay we have effectively taken care of, but that's basically for CPU and memory. We never had a use case where we had to optimize it for network, so first stumbling block. Standard metrics. So when this comes in, it's the platform integration. We are integrating it into eBay platform, where the terminologies that we use are way different from the terminologies ESB came with. WSO2 terminologies were not straightforward for us to translate. And if we were not to translate, all the metric and monitoring that we have in place would misunderstand us. So we had to do the translation. We had to effectively give them what latency meant and what latency is bad, what CPU utilization meant, and how much of CPU utilization is good to go with. We have something called disaster recovery thresholds. We ensure that all our servers are capable of taking at least twice as much traffic under a disaster. So if they are not capable enough, then it gets monitored and notified. So for that notification to be in place, we had to give it the right translations. So that had to be done before or while we were on the cloud. Otherwise, all the tools that were involved would either not react or overreact. Either of them is bad. OK, so one more nightmare. So we have all of this running. So how do we know whether it's scalable? We were always running on bare metal, and we had the luxury of all the resources that we had. Now we have cut them into smaller chunks, and we hope that it's scalable, but how do we test it? We definitely have to test it either in production or create exactly the same environment in our QA system to test it, which was interesting because any given ESB that we had at least a few hundreds of endpoints, and all of them were taking real production traffic, and there was almost no way for us to replicate them in QA. But yeah, we ended up doing. We'll see what are the problems now. Now we enter the ESB realm. So this is where we got quite a lot of help from the WSO2 support. And if I were to bucket them in which of them were the biggest that we made changes, which is, again, I would say very superficial, we had to change configuration. Sounded right. And why is that a big bucket? Because of a lot of legacy that we had. We have been using it for at least 5 to 6 years or even more. And we continue to add configuration. Like any other big, good company, we add and never delete. So it only grew in complexity. Whether we use it or not, the configurations were there. And definitely, profiling. This is where we could enhance, or we could actually leverage some of our knowledge from the performance team, which I'm part of, while we were profiling for other applications. We just tried to see if we could leverage the same tools that we had and try to see what's going wrong. So there are some interesting things that we found out. I'll get to that. Metrics and logging. We'll get to the details. This is the current topology. So just to quickly run through, not go to the details, we have the load balancers, which are the firewalls, and the load balancers, which take the traffic from external clients. And they have some geosensitivity where they ensure that geographically sensitive or geographically distributed data go to the appropriate pools. And we have the ESBs, where all the traffic that comes to the external site, not all of eBay's traffic, but most of or some specific traffic goes through ESB. And internally, ESB does the routing for us. We are using ESB mostly for routing, and to some extent, we do have the protocol translations, but majority of our use cases is routing. And a quick view is ESB gets the data and routes it to multiple pools or endpoints. Pool is what we call. Every endpoint is a pool for us, so that's the internal terminology. And every pool that we hit is actually a load balancer, and behind the load balancer is the actual pool. And it's distributed across multiple co-locations, so that's where we get a DR. And the idea behind this is the complexity is because if one of the co-location goes down, we should have an effective way of redirecting traffic to the other co-location and ensure that we don't have the cascading effect of one co-location failing, causing another co-location to fail because of overloading. So that is something we always have to ensure. So, well, I just talked about what's the complexity that we have in setting up a LNP environment, which is load and performance testing. So we had to sandbox the whole thing. And why I did mention this is because, as usual, it works in LNP, it works in QA, it doesn't work in production. Or it doesn't work in QA, it doesn't mean that it will not work in production. So we had to really come up with a very valid test scenario, test setup, which meant that we had to replicate all our complex configurations and create some endpoints and create a lot of variation, create faults to sort of match what happens in production. And that was a lot of effort. And that was worth the effort because that gave us a lot of further profiling or all the testing, all the variation tuning that we had to do. We all did, it had to be done on this setup. So it was worth the time spending on getting a very valid sandbox testing setup. Well, worth the mention there. And definitely, the things that we had to change was threads. Obviously, we moved from bare metal to smaller VMs. And apparently, we had not really bothered about threads when we were on bare metal, more so because it had a lot of resources and we never exhausted them. Here, any small change caused tons of contention, and it all takes one contention for the system to choke and fall over. We hit a lot of such problems, and a particular type of or a pattern of faults could topple the server. So those were the interesting things that we found out here. I'll maybe not go into a lot of details, but definitely thread tuning. Yeah, when you go to cloud, you should be worrying about thread tuning. And you should understand what these threads are. There are a variety of threads that we had in ESB. The reactor threads, they stick onto the processor, so you definitely don't want to have a lot of them. You want to have as many as your processors are. And worker threads are completely async. So based on your workloads, you want to synchronize them. You want to configure them. So just some types of threads, but yeah, we had to go through each of them painfully, and some of them were trial and error, unfortunately. And this is where our legacy came into picture. We had a complex filtering logic, and we had filters for every endpoint, and we had few hundreds of endpoints. So just imagine what all goes in there. And as usual, we tried some smart things. We copy-pasted the regex, which apparently were pretty expensive. And the interesting thing that we found here was context. So this is, I guess, very specific to ESB, where if you don't set the right context, it's a lot more expensive because it goes up to the global context and tries to get the variable. So it's a little very specific, which was a good learning. But yeah, something to know about when you're dealing with ESBs. OK, so trace and log level. So we had a lot of logging enabled. And we just tried to be good. We wanted all the information that we could get, but obviously we know that it's pretty expensive. And so we had to turn off a lot of logs and tracing. And we got a lot of help from WSO2 to enable some critical logging to happen or change the log levels. So the really required information would still be logged. And we were not losing the real errors versus the possible warnings or errors. So these are very minute things, but made a huge difference. So we wanted the logs, but not all of them. So that's where we know that this was very expensive because this was taking a lot of CPU when we turned on or off logs. But the other extreme was we would not get any errors if we would turn off, go to a lower log level. So again, just worth a mention there. Okay, so profiling. So what do we do? We use IBM, Oracle JDK in there, and we also use IBM JDK. But for this profiling, we went ahead with JMC available with which is Java Machine Control. So it does provide us the hotspots, the method hotspots, and the contentions, which were pretty interesting. We found some really interesting stuff on what is causing the hotspots and what's consuming the little CPU that it was using, and what was causing high latency. And just one interesting mention that I can say here is most of what we found was configuration errors and not necessarily code errors. Good thing was we didn't find any code problem in WSO2. It was definitely some configuration changes that could do away with any of this contention. And yeah, we had our own mediators in place. That was our piece of code which would get executed when transactions happen or come in. So not necessarily, we didn't find a lot of errors there too, but all of it was configuration. So it was a lot easier to deal with. And definitely GC. So the default configurations that we had from IBM JDK is what runs in production. So the default configurations were not suitable for especially ESB, given that ESB is short-running tasks, and they generate a lot of short-lived objects. So we had to go ahead with, this was just a small snippet, but we had to come up with a lot of tuning parameters that we had to put in. These were the ones which gave us the bigger benefits, but there were a lot of other options that we have put in there which made things a lot better and reduced our GC overhead. And all we were monitoring was how can we minimize our GC overhead. And yeah, that is definitely a big factor. Just a view of what we got. It doesn't mean anything here, but if you look at it, it was a database access which was pretty expensive. And that's because we were trying to put a lot of statistics into the local DB that ESB maintains. And the fact that we were writing to the DB, we were actually preventing a lot of other threads which were trying to read from the same DB. And that was really expensive. And by itself, write was not very expensive, but just that it was holding on the read threads, which were few tens or sometimes hundreds, which was causing the higher latency. Okay, this is pretty interesting. Now that we are done with all the tuning, we went through QA, and everything looked fine. Now we put it in production. What happens? One bad endpoint caused all the problems. So it is a typical cascading effect where one endpoint slows down, puts backup pressure. The ESB holds on to all the threads. The moment ESB holds on to the threads, the LB which is in front of ESB is choked. There's a lot of stacking. Once that stacks, all the connections that is coming from the LB to the ESB is choked, slows down, and ESB is completely hosed, and ESB internally causes downstream pressure to all the other endpoints. So effectively, the whole ecosystem is slow. And if you look at it, wasn't that an easy problem to solve? Not necessarily. It's because all of this happens in few seconds. And the resolution of our metrics generally is in minutes. And how do we solve this? It only happens in production, by the way. So they're not easy to recreate in, you need to have a bad endpoint. You need to have lots of endpoints. And you need to have the whole ecosystem and the variety of calls that come in. And a lot of these calls have either high load, small requests, high latency, all varieties. So that's where we got some more help. And WSO2 team gave us very detailed metrics. and they provided us MX beans where all these details were aggregated, which really helped us narrow down to the root cause, and we had enough visualization with which we could look at how the metrics were behaving. And now, yeah, certainly we are better off. And this is what I was telling about. So error reporting, now we have whether the root cause of the problem is downstream or upstream. Otherwise, before we figure out, it was the whole ecosystem which used to be down. And well, who was blamed all the while? It was ESB, because ESB was the one which was showing very high latency for no problem of its. So we had to really nail it down. And the detailed metrics that we got was pretty interesting and very helpful. OK, this is the last slide, by the way, so we'll have time for discussion. And are we done with it? Life is good, specifically, but we can always make it better. And what are we doing to make it better? We are trying to see if we can separate the ESBs so that they handle specific load, so that we don't get into a problem where variety or different types of loads are being handled by the same instance, and we don't know what or which combination of it can cause a problem. So why not separate them? So if something is affected, only that vertical is affected, and we know how to solve them. And a few more things. We are not dealing a lot with ESB does change a lot of header and the body. And most of what we do is just change the headers. So why not go with the very light mode of transport, which does only the header changes? That's, I'm sure, going to help us a lot. And then for the cloud, we are very good with the cloud, as I said. So, but all our VMs are optimized for optimal usage of CPU and memory. So there is a huge opportunity for us to optimize our network or I/O usage. So that's something for future to make things better. Whatever you're interested in, we can go deeper into it. Was it like a story? Yeah, sure.
So you said you separate out. You said you separate out some use cases on different installations of the ESB. Mm-hmm. How do you manage what goes where? What keeps your deployment
So we
organized?
have ESB pools. So it's, I mean, the right term I would say for the catchy phrase is it's ESB as service. So we would deploy ESB service per type of request. So we had to differentiate it per type of request. Not necessarily every URL or URI, but we could categorize them based on what is the endpoints, what type of endpoints are they serving. Basic differentiation for us was, is the request payload big, small, or medium? And we know that if the request was big, ESB had to deal with it a little differently based on our mediators. And if we were to separate the large payload request from the smaller payload request, life was better. We know if the problem is coming from large payload, we know how to fix it. But a combination of this, if it causes a problem, that's when life gets difficult. You need to have two small payloads with one big payload to cause a problem, giving an example. So right. You don't want to solve that problem.
So what kind of data are you passing through here? Like, what's the load on your system?
So in terms of data that's getting passed through, the requests were a lot simpler, and we were just manipulating the headers and not the data, not the body. And in terms of requests going back, they were depending on the query that was part of the request. So it could be really small to huge, depends. So it's just the request that would determine the response payload.
So what kind of queries per second is your system dealing with?
Oh, in terms of transactions per second, we consistently run at the rate of at least 400 transactions per second, which sounds low, but we are running on a really small VM. So our VMs are 4-core.
You identified a performance issue that was contention-based, and you said that it had something to do with the registry you were using. Mm-hmm. Were you initially using the local registry, and then by moving to config or governance, could you explain?
No, this is the registry available within WSO2, and that's the only product we seem to be using. We don't have governance in place. And the problem for us is we had accidentally or by default enabled the statistics to be put into DB, which we were anyway not using. We had a lot of statistics, and we were trying to write them into the DB.
So to solve that, so with the WSO2 registry stack, and there's a local registry.
Yeah.
So did you move to the config registry, or?
It was just a stats registry, and we had to turn it off. So all we had to do was we didn't want the stats to be captured in the DB, and it was the statistics. It was not the config. Config is still in the registry, by the way, so it's good to be there.
Sorry, I have 2 quick questions. One, was there a conscious choice to use the IBM J9 in production versus development in QA, and was it performance related, or?
No, it was not that. So in the QA, we happened to use Oracle JDK because we had the tools to do the profiling, and we had all the metrics in place and the mechanisms to run Oracle JDK. But yeah, it was not the performance.
Okay, and then the second question is, it looks like you're using the ESB primarily for routing. Are there cases within your architecture where you're using the ESB for endpoint implementation as well?
Yeah, we have. Just that majority of it is for routing.
You mentioned in your slide when one bad endpoint can causing the performance problem of the ESB.
Right.
Can you please elaborate on the detail matrix? Is it a tool provided by WSO2 for you to solve that problem?
Yeah, right now it is the metrics provided by WSO2, which we continuously log to our eBay platform logging. And we have metrics and visualizations in place to look at these metrics, which help us solve. But in terms of what caused it, most of what we were looking for was the latency. There was an increase in latency. We get metrics per endpoint, but we always would get, or we still continue to get it per minute. So in a minute, all of this would have gone bad. So it's like who started it, which is the symptom versus which is the root cause, was very difficult to narrow down to. So by the time we saw, all of them would be bad, but of all of this, one of it would have been 1 or 2 seconds before they were bad, and it caused everything to be bad eventually. It was just the timing. It was too fast for it to go bad. Okay, thank you.